Okay, welcome back. Today we are going to discuss PGF plots. Okay, so these PGF plots are really very powerful tool in Latex. You can plot graphs, any if you have data using that also you can embed your graphs directly into your document. And for that you must have Tikz and PGF plots packages. Okay, so that needs to be included. This MCAM I'm using because my figures uses a lot of some chemical names that should be actually placed on the figure itself, and that's why this MCAM, otherwise it is not needed for you. uh, Graphics, of course, that has to be mandatory when you are going to include some graphics. So here is an example. Okay, so let's see that what exactly the minimum thing you need to plot a PGF plot. So if you are giving just begin axis, and between these square brackets you can give all the options how your axis will look like. Then we have the actual plot. Okay, and then end axis. That's all, and everything has to be in a text picture environment, and this can be inside a figure environment. So let's say Control X slash figure, because figure can have captions, right? And you can give it my first PGF plot. Okay, so let's compile and see how it looks like. Just okay, so I think it has started now. So if we will compile it, let's see, I have put it in the figure environment. Where is, oh, so because it is a figure, it has gone to next page. You will have to force it on this page only here. Right, so now you can get that here. Now you can see that by default it has taken some value -5 to 5 for x. I have not given any instruction. So these are some default values. Depending on the nature of the graph, it takes some default domain and range. Uh, you can the axis, okay, the whole plot. Okay, so this blue color is plot. Rest of them, the things are actually axis. So the axis can be controlled using various parameters. These are, I have mentioned only few, when there are many. And also you can see that we can plot simply by writing x. Okay, add plot x. Likewise, you can also write x square. So let's say another one, x square. You can also add. Okay, now you see the y-axis has already been changed. Now if you will make it axis lines is equal to middle, then it will be around 0 0, the line will be created. You can provide x label and y label also. So let me comment it. You can give x label and y label, so that will be x axis and y axis notations. So here it is x, y is equal to fx. Simple. You can restrict the domain also. Okay, so for example, you want x minimum is equal to 2 and x max is equal to, sorry, x minimum minus 2 and x max is equal to 2. That could also be done, right? You can see. Likewise, you can have samples whether you want to, because there are very, right, only I think 10 samples over here. If you want to see the samples, you can write mark is equal to O, let's say. So mark will be given 0 4. So that you can get it. Now here you have 100 samples. Let's say you plot only 7 samples. That also could be done, right? You can see the square curve, how it looks like. Y is equal to x square, because the number of samples are very small. Let's take it 15. I think that will be quite good. But still, if you write just smooth, that along with the plot properties, write smooth, so that will be sorry, so that is already x is okay. X square is needed, right? So that will be smooth. So more smoother curve can be plotted. Now you can have the mark is equal to star. Let's say. So where are the data points you can see? So these are only the data points. Okay. So now you know how to control x minimum, x max. Likewise, you can also control y minimum. Is equal to, let's say I'm plotting only from 2 to y minimum is equal to -1. Let's say -1, y max is equal to 2. So the plot will be adjusted accordingly. Y minimum, y max. Sorry. Right. So you can see the graph is from -1 to 2 only. So this is a normal plot. If you don't say anything, it is by default x and y axis are linear. You can plot other curves also. Let's assume you write it instead of x, you can write y is equal to 3x plus 2 plus 1. Let's say. Okay, so this 3x plus 1, that should start from at x is equal to 0. It should start from y is equal to 1. So let's see whether it is true or not. Yeah. So at x is equal to 0, it is showing 1. You can increase the number of points. Okay. Along with that, you can have legends, right? So for example, for each marks, you have given legends. So legend will by default it will take for the previous one, whatever the plot was there. Okay, for example here fx is equal to x, that will be for this blue, and this one has no legend. The last one has y is equal to x square has a legend. Y is equal to x square, why it is saying add legend. Okay, add third one also. Y is equal to x squared, this is x cube. X cube. Now it will be perfect. Okay. Now by default it will come on the top right corner. But if you don't want over there, then you can control it from legend position option. It is northwest. Okay. So northwest means you are forcing it to on the top left side. Okay. Let's see, you have more area over here, so put it on the southeast. South. You can also remove the box over here. You can also change the fill color, etc., etc. Many things you can do. So I hope that now you can work with PGF plots, how it is working. Very simple. You have a figure environment, right? Figure is centered, and in that you have a text picture, right? This text picture has a graph, okay? That that is within begin axis and end axis. Whatever you will plot outside, that will be part of the text picture but not part of the graph. Okay, so you can also draw let's say at 0, 0 circle, let's say 1 centimeter. So at 0, 0 it will draw a circle of 1 centimeter, right? Fill draw. So fill draw, then you will have to give the option for fill. Fill is equal to blue, and opacity is equal to 0.5. You can see. Okay, but in our discussions, what actually we want is not a normal linear plots, but on semi-log plot we want, and you can see many things. Now you can see that the axis is made semi-log in y. Semi-log y-axis, that will make y-axis logarithmic. Likewise, you can have semi-log x-axis. So x-axis will be made semi-log, logarithmic. Or log yy is also possible, xy is also possible. Width and height you can control of this axis. Then x level, y level, that we had already discussed. X minimum, y minimum we have already discussed. These two things are especially for controlling what are the Tikz points. Okay, so these are the Tikz points. Okay, so x Tikz and y Tikz. You can see that I have not given 15, so 15 is not plotted over here. If I will give 15 also, then the graph will show 15 at its own position. Right? Likewise, if you are giving x minimum is equal to 1 e to the power 1 e 10, even if you are giving x Tikz at 1 e 8, it will not be visible. Why? Because it is starting from x, y minimum is 1e10. Okay, so those ticks which is in the range, that will be shown only. That's one thing. Then grid option is also there. In last image there was no grid. You can say that major grid or major and minor both grids you want. So that could be drawn. Tick level font styles you can actually change. Line style also you can change. Okay, axis line style. Let's assume you don't want black but you want blue. So the axis line style that will become blue. So no one should do those kind of innovations, right? Axis line legend style. Okay, so legend which I had talked about, that can be fill by default, that is white, but you can make it other fills, and also you can remove, so that can be transparent. Fonts also you can decide. Okay, so let me give the data for that. All these data again, I will read them one by one. So the plot which you want, that can be either plotted through equations as we did last time in the previous example of linear one, or if you have data that can also be included, that can be uploaded in the same folder and it can be plotted. So I have uploaded many data and these data are like this. Sorry, the preview is not available. You can see the preview. So any sample you can see. So let's say 1 second 800 degrees centigrade. It is like the header is Z and AL. In Z direction it is actually the aluminum presentation that is being done, right? Yeah, so I was saying that here it is Z and AL, that is the header lines, and rest of them are data which is separated by comma. So it is logarithmic type of data. It is going starting from 1e18 to 0. Okay. And in the main file, how you can include it, so rest of the things I will come one by one. So add plot. Okay, you give the plot specifications, so what will the color, thickness, mark is, etc. And then write table. So the data has to be taken from table, not from equation, as in case of last example. And give the table specifications, right? So x, that has to be taken from Z column, the first column in my data. Y is AL, and then column separation is comma, right? So you can see that the column separation is, so data are separated by comma. Okay, this is a CSV file. And then you will give the file name, then add a legend for the same, and then plot it. You see, so this data has been plotted from one s800c.csv file that is already there. A legend has also been given, but legend is not being, yeah, legend is shown over here. Okay, you can see. Likewise, you can also plot another data on the same graph by just adding this, and let's assume I want to plot 2 seconds 1100. Okay, so I will change the file name as 2 seconds 1100 C. Yeah, C, and change the legend also. So write it at temperature 1100 centigrade for 2 seconds. Even though I am writing a very long way, it will not be like this, just to explain that how it works. You see, so that data is also plotted over here. Now to distinguish, you can change the color, make it blue. Now you see that not only the color of the graph has been changed, but also the legend. Okay, so that has also been changed. If you will write it, mark is equal to star, then marks will be star, as well as this star will come over here also. Okay, so let's make it the same, 2s 1100c. Now it is very easy, right? If you want to plot all the data over here, then you need to just do Control C, Control V, and then what is the other data? Let's check it. So at 1100 you have 6 seconds also. So that 6 seconds 1100, 6 seconds 1100. Change the color to red. At 1000 also you have, right? So you can have 6 seconds 1000 degrees centigrade, 6 seconds 1000 degrees centigrade. Then Control V. Instead of red, you can write it green. You can write it olive. Let's say 4 seconds 1000 degrees centigrade. 4 seconds 1000 degrees centigrade. So this will add up everything in this plot. You can see that legends are also getting done, right? Now if you have to plot a line on this axis, to draw that, I have already drawn over here. You can see, let's look at one piece of code, a fill draw. Likewise, as you are drawing the fill in Tikz, so it will work here also. Fill draw, fill is equal to red, draw is equal to none, opacity is equal to 0.1. Here the point is given in terms of axis. Okay? So this is not the absolute points, but axis points. Okay. So it is from 15 1e8, is 15 1e8 to 25 1e18. You can see. So that this light gray, because the opacity is almost like only 10%. It is opaque, 90% transparent. That's why it is not red exactly. Let's make it 0.5. You can see the change. Yeah. Right. So only this block I'm talking about. You can change it, and let's assume make it 1:17 or 16. Then it will be 25 1:17. So 16. So up to this point only it will be, this fill draw will be there. So one rectangle. This silicon has been given as another node over here. So you can create your own desired one. Okay, you know that where is the silicon boundary, where is the silicon dioxide, hafnium oxide, titanium nitride boundaries. You know better, right? For your problem. So likewise, you can create PGF plot. In fact, you don't need it. In my problem specifically, uh, this one was needed, and that's why I had given. Right? So doesn't matter whether you are giving these blocks or not. It will not change your graph. Graph will be as it is. Only the colors, boundary colors, that will be gone. So that is just for added augmented image, so that more inference can be drawn. It is easy to explain it to the reader. Now, in scientific writing, it is very important that the reader should actually get everything just by looking at your diagrams. Okay, you need not to write many things, otherwise they will ask many questions. I hope that you have understood about the PGF plots, how to use it in your document. Now, once you have one format, you can copy and you can repeat it again and again, and you can change the data, whatever. Rest, I think once you will be using it, you will find that it is really, really very, very easy. Okay, so let's assume I want to plot at 900 degrees centigrade data over here. Okay, I just need to change the names. 900. All data is available in this folder. 800, let's say 800 data is also available. If you go to origin just for plotting, I think that will be quite difficult. So now it will add another image that would be having all these plots. You can see. So for 900 and 800, all the uh, dopants are limited only up to the titanium nitride. They are not going into the silicon. Right? A clear difference between 1100 and 900, 800. If you go to the origin, that will take too much time. Okay? And even that you can draw it. Now, in your research document, uniformity is also very important. So it will be very much uniform, especially it should be used for scientific writing. Origin we need when we go for some kind of curve fittings, etc. Okay, peak fittings. Some more mathematics are required, some signal processing is required. Then we use origin. Otherwise, this Latex is, I think, very sophisticated. Even you can use signal processing here also, but for that Python library that has to be added. I hope that this video will be helpful. It was a detailed one. Thank you.